Hello grade 6 students, how are you all doing? This is the last science lecture video for semester 3 and we are still talking about matter and the elements that are the building blocks of matter. There are almost 120 elements organized in a periodic table. Most elements are metals and solids at the room temperature. To represent an element, we use symbols. For example, the letter H stands for hydrogen. C represents an atom of carbon. N for nitrogen. O for oxygen. Cl for chlorine. Ne for neon. And He for helium. These elements are non-metals. The hydrogen and the helium, for example, are gases at the room temperature. The sodium, the calcium, the iron, the copper, the silver, gold, tin, and aluminum are metals. When elements combine with each other, they form compounds. Here are some examples of compounds that surround us. The carbon dioxide. This is a gas that is present in the air around us. One molecule of carbon dioxide contains an atom of carbon and two atoms of oxygen. So there are two different types of atoms. For this reason, the carbon dioxide is considered as a compound and not an element, since elements are pure substances that show one type of atoms. One molecule of water shows two atoms of hydrogen and one atom of oxygen. So here also we have two different types of atoms. So water is a compound. Do you remember the ammonia, which is the toxic substance that is eliminated out of the organism? So one molecule of ammonia has three atoms of hydrogen and one atom of nitrogen. Today's lesson is about properties of compounds. Compounds are divided into three different categories: acids, bases, and salts. Acids and bases are two groups of chemical compounds with opposite properties that are seen and encountered in everyday life. But where are acids found? Let's take some examples. The vinegar, for example, contains the acetic acid. Laban, or the yogurt, is rich in lactic acid. You can find the citric acid in lemons, in oranges, and the malic acid in the apples. Aspirin contains salicylic acid, while olives are rich in oleic acid. Vitamin C, or ascorbic acid, is found in some medicines that we use when we feel sick. Soft drinks contain carbonic acid. We find acidic substances in many foods, while bases are found in some household and toilet products such as soap. Usually, the household detergents contain bases. Some, like the bleach or the drain cleaner, are dangerous and should be handled with gloves for safety measures. For the moment, soap and shampoos are toilet products that contain bases and that can be safely handled. The glass cleaners contain a base that is also safe to use. Weak bases are found in toothpaste and in baking powder. Antacids contain also bases. These are medicines used by patients to relieve their heartburn and their stomachache. What are the differences between acids and bases? Foods containing acids are used in salads, sauces, and these acids are weak, edible, and they have a sour taste, while bases have a bitter taste. Bases feel slippery, while acids do not feel slippery. Solutions with a pH less than 7 are acidic, while solutions with a pH greater than 7 are basic. But what is pH? pH is a scale of acidity from 0 to 14. It tells how acidic or basic a substance is. More acidic solutions have lower pH, so acids have a pH that is less than 7. More alkaline or basic solutions have higher pH, so bases have a pH that is greater than 7. Substances that aren't acidic or basic are called neutral solutions, and they have a pH equal to 7. Here are some examples of chemical compounds, acids, and bases. Let's see. Gastric juices, the tomato juice, and the urine are considered as acidic substances or solutions since they have a pH that is lower than 7. The human blood has a pH of 7.4. The hand soap pH equal to 10. The household bleach pH equal to 12. So these compounds or these substances have a pH greater than 7, so they are basic substances. Water has a pH equal to 7, so it is a neutral substance. Let's play this game and identify if some kinds of solutions are acidic or basic according to their pH. Let's take the water as an example. They are telling us that water is a neutral solution. The pH of water is equal to 7, so yes, it is a neutral solution. Blood, for example, I will put some blood in the container and then check the pH of the blood. It is equal to 7.4, so it has a pH greater than 7, a bit greater than 7, so it is a weak base. I'll go for coffee and put some coffee in the container. Let's measure the pH of the coffee. So is it acidic or basic? It's acidic, excellent, with a pH lower than 7. Last example, let's go for the orange juice. Orange juices have a pH equal to 3.5, so less than 7. These are acidic solutions. Another interactive activity to identify the type of a solution, if it is acidic or basic or neutral. Let's test the ammonia. Is ammonia acidic or basic? We will use the color indicator and then compare the color to the pH color chart. The color shows that the ammonia has a pH equal to 11. So is it acidic or basic? It is a base since it has a pH greater than 7. Another example. Oven cleaner. Let's test it. Let's compare the color obtained to the chart. This is a strong base since it has a pH equal almost to 14, a pH greater than 7, so this is a base also. Cola. Let's test it. Orange color. Let's compare the color to the chart. Cola has a pH equal to 2, so this is an acidic solution. Last example. The saliva. Our saliva. Is it acidic or basic? This green color shows that the saliva is neutral almost, with a pH equal to 7, so the saliva is a neutral solution. Let's go back to this table comparing acids to bases. So we said acidic solutions have a pH lower than 7, but basic solutions have a pH greater than 7. Acids turn the litmus paper to the red color, while bases turn the litmus paper into the blue color. What is the litmus paper? Most acidic and basic solutions can be dangerous, so we are not allowed to taste them nor to touch them. So how can we identify them? These solutions, acidic or basic, can change the color of some substances like the litmus paper right here. So the litmus paper is considered as an indicator. So to identify if a solution is acidic or basic, we use color indicator. So the litmus paper is a commonly used indicator that helps us to identify if a solution is acidic or basic. Let's take a look. Here is a blue litmus paper dipped in an acid. The blue litmus paper turns red. This shows that this is an acid. When we dip a red litmus paper into a base, it turns into the blue color. So the red litmus paper turns blue. In a neutral solution, nothing changes. The litmus paper is one of the color indicators used. Let's go for this simulation to check how indicators work. I will take the water as an example of solutions and put the paper in the water to see what are the changes that will happen. Look at the color of the paper. If we compare it to the pH scale, it's the same color. Right here, it's the orange. That means, or that shows, that the pH of the solution is equal to 7. So water is a neutral solution with a pH equal to 7. Let's change the solution and use a strong base. I will put the paper in the solution. Look at the color of the paper. Let's compare it to this pH color key. It shows that the pH is equal to 12, almost 12. The pH right here is greater than 7, which means that this is a basic solution. What happens if we choose a strong acid? I will put the paper in the solution. Look at the color of the paper. It shows that the pH is 2. The pH is equal to 2, so the solution is acidic with a pH lower than 7. Acids are solutions with a pH lower than 7. Bases are solutions with a pH greater than 7. Solutions that aren't acidic or basic are called neutral with a pH equal to 7. An example of neutral solutions is the water. Salts are also compounds, and they exist in the form of crystals around us. An ACl, which is the table salt, is an example of salts that we encounter every day. The reaction of an acid with a base is called a neutralization reaction, and the products of this reaction are a salt and water. For example, the reaction of hydrochloric acid HCl with sodium hydroxide and AOH produces a solution of sodium chloride and ACl and some water molecules. Mixing an acid with a base, here we have the HCl as an acid and AOH as a base, results in a chemical reaction and gives an ACl, which is a salt, and water. This is the general equation of a neutralization reaction, When you mix an acid with a base, you will get a salt with water. This is the word equation of an example of neutralization reactions, where the hydrochloric acid combines or reacts with the sodium hydroxide to give the sodium chloride, which is a salt, and some water molecules. Here is the chemical equation where we use the symbols of the compounds. And this is it. Compounds can be acids, bases, or salts. To identify if a solution is acidic or basic, we use indicators and we use the pH scale. If the pH of the solution is less than 7, so it's acidic. If it's greater than 7, so it's basic. Some indicators, color indicators, are used to identify if a solution is acidic or basic. Since we cannot taste them or touch them, they are dangerous sometimes. And these indicators change colors according to the type of the solution used. The table salt is an example of familiar salts that we encounter every day. I will be happy to answer all of your questions if you have any. Thank you for watching.